Hello. For question 13 here, we're using, so what I have here is I have an angle. So the second I have an angle, I know I'm using trigonometry, the SOHCAHTOA. So first I need to do is I need to label my triangle. So if this is the angle I'm given, what's the side opposite of this? It's this one. This is my opposite. This side is opposite of my right angle, which means this is my hypotenuse, which means this has to be my leftover side, right? So we have hypotenuse, opposite, and adjacent. Now the two sides that are currently that I'm either using or I am trying to find, well, I have something with the hypotenuse and I'm trying to find, and I'm trying to find the opposite here. Sorry, I'm just going to close my window because of the train. So I have opposite and I have hypotenuse, OH. I need to use sine. So I'm going to have sine. So it's always sine of the angle is equal to opposite over hypotenuse here, right? Now in this case, my angle, it tells me it's 59. If it didn't tell me, I would have to put a blank angle in there. But it does, so I'm leaving it as 59. My opposite in this case is just x. So that's what I'm trying to find. That's what it is. And my hypotenuse is 17. Oh. So what I need to do is I want it to get x by itself here, right? So what I need to do is I need to get rid of this 17 here. So to get rid of something on one side of an equation, I have to do the opposite. So the opposite of x is being divided by 17. So to separate it, I need to times by 17. But I don't just times one side. I have to times both sides by 17. The right side here, those get canceled out, right? The left side, well, it's sine of 59 times 17 is equal to x in this case. So now I can actually throw that in my calculator here. So sine of 59 times 17, I can see the answer for 13 is 14.6. 14.6. Now for question 14, which is what the assignment is, I do it the same thing, right? Here's my hypotenuse, here's my opposite, here's my adjacent. This is going to be the exact same. It's going to be answered the same way because you're still using your opposite and you have a hypotenuse here. Sorry, my highlighting is messing up here. So it's still going to be the exact same. It's done the same way here because your x is on the top of the fraction. Now, let's say, for example, let's look at this one here. So let's look at this one here, question 15. So I have A and H. Actually, no, that one won't work. This one here would be opposite, hypotenuse, adjacent. Yeah, so let's look at 16 here. So this is my hypotenuse. Here's my opposite. Here's my adjacent. So I need to use A and H. It'd be cosine, ka. So cosine of 51 is equal to adjacent, which is 10, over the missing side, which is x. So for this one here, the difference between these two equations here, I mean, yes, this one uses cosine, this one uses sine, but it is the same thing in a sense. The main difference, though, here is the location of the thing I'm trying to find, of x. Over here, it's on the top of the fraction. For question 16, it's on the bottom of the fraction. So I actually need to do what we call a two-step, because one, I need to get rid of x. It can't be on the bottom of a fraction. So I times both sides by x, right? Just like before, times by x. I do that to both sides. And now I have cos of 51 times x is equal to 10, right? But now I need to get rid of this part here, right? So this has to go away because I want x by itself. So I got to do the opposite, which is I'm going to divide by cos of 51 to both sides. And I would get x is equal to 10 divided by cosine of 51 in this case. And that would give me, some type of an answer. Maybe it's 5 or something, or it's probably going to be closer to like 12. But anyways, that would give me an answer here. But for question 14, it's going to be done the exact same way as question 13. You really just change the numbers in this case. So let me know if this helps.